Hello, this is Youngjin Song. Let me briefly introduce our paper. Since GEO is higher in altitude than the MEO used by most GNSS satellites, the satellite signals must be received from the opposite side of the Earth. In this case, the visibility of satellites is reduced due to the Earth's shadow. To improve availability and satellite geometry under these conditions, sidelobe signals are utilized. Signals located in the sidelobe regions typically exhibit weak signal power and high Doppler shifts. Therefore, longer integration times and a wider Doppler search range are required to acquire these signals. These factors negatively impact acquisition time, highlighting the need for detailed analysis and further research in this area. In this study, we propose a comprehensive mathematical model to analyze acquisition time performance. The model is generalized for multi-constellation and multi-frequency signals, making it applicable to any type of GNSS signal. The model consists of a correlation and its statistical characteristic model, a search space model, and a mean acquisition time model. In particular, the search space is determined by taking into account the operational characteristics of geostationary orbit and the properties of navigation signals. The mean acquisition time model is developed based on an algorithm implemented in an actual spaceborne receiver. Specifically, the fast acquisition algorithm used for GPS L1CA in NASA's Navigator receiver is generalized to support multi-constellation and multi-frequency signals. A detailed analysis is conducted on this algorithm in terms of computational load on the processor. To incorporate the geometrical distribution of satellites and signal characteristics at geo altitude into the analysis, a geometrical simulation was conducted. The publicly available transmit antenna patterns of GPS, Galileo, and QZSS were applied to the simulation. Based on the proposed research methodology, acquisition performance analysis results are presented for various civilian signals in a multi-constellation and multi-frequency setting under realistic assumptions reflecting GEO operational conditions and spaceborne receiver hardware characteristics. To validate the proposed model and derive the results, Monte Carlo simulations were conducted using a software simulator receiver pair. Signals were numerically generated and acquisition was attempted to measure the actual time required, which was then compared with the predictions from the model. Although slight discrepancies were observed, the proposed model demonstrated sufficient accuracy for predicting acquisition time during the development of new receivers or algorithms. Thank you for your attention. If you are interested in learning more, please refer to the full paper.